Hi, I'm Joshua Kemble, and welcome to my live stream. Let me make sure my audio is good. Hopefully, it is. I'm going to be probably listening to like a Francis Collins lecture and kind of commenting on it while working on layout stuff. I've been on and off working on my comic all day, off stream and on stream. Who am I? I'm Joshua Kemble. I've been a freelance illustrator and graphic designer for about 20 years now, and I've been doing art direction for about 8 of those years, which makes me really old. So, anyhow, I do these live streams when I'm not working as an art director or graphic designer or illustrator, and when I'm working on graphic novels, like the 2 graphic novels that I have out currently. One is Jacob's Apartment, which is this book right here. It's a 128 page full color graphic novel about 2 young early 20 something characters, Jacob and Sarah. Jacob has recently lost his father to cancer, and that's caused him to start questioning his belief system. And Sarah has just gone through a breakup. And basically, both of them are questioning their identity and are being plagued by dreams, like really vivid dreams that kind of allude to their childhood or allude to their like search for meaning. Jacob dreams of himself as this like childhood stuffed animal called the Carnosaur dinosaur, which is a stuffed animal that he got when he was a little kid. And Sarah dreams of swimming and drowning. And then sometimes like seeking something deep in the ocean. And so they're both having these really vivid dreams and finding themselves drawn to each other. And as they find connection with each other, their dreams and reality start interweaving in a way kind of like if you took Eternal Sunshine for the Spotless Mind and put it in a blender with Ghost World. If you like that flavor, you'd like this book, Jacob's Apartment. Plus, it's got really nice typography, beautiful illustrations, all by me. And it's written and illustrated by me and put out by Graphic Mundi, which is an excellent publisher. Actually, recently just did a pull quote for their book, The Mayor, that just came out by Seth Martell, which is really, I highly recommend. And then also we have, these are my last 2 mentionings of stuff I have, and then we'll get into the content. 2 Stories, which is basically a graphic novel about faith and mental illness. It's hand lettered and hand inked. It's black and white graphic novel that talks about my journey learning how to deal with depression and caregiving for somebody with panic disorder, as well as a lot of childhood stories, like dressing as Indiana Jones for an entire year before cosplay was a thing. So if you're listening, let me know if the audio is good. I'm still kind of figuring out how to dial in the settings on my new mic, but I hope it's better. I hope it's a more pleasant experience for you guys. And we're going to basically potentially be working on layout stuff that I'm going to be doing kind of off screen, and we might comment on a Francis Collins video. So my goal is on this stream to work on Not Death But Love, the Strange Supernatural Story of Elizabeth Barrett Browning, which I have a pretty looming deadline for quite a lot of pages. And we're going to be working on layout for page 74, but most of that will be off screen. And listening to Francis Collins talk about DNA because it's super nerdy and awesome. So this is a lecture called the Lewis M. Slaughter National DNA Day Lecture from the National Human Genome Research Center. And I think it's actually really exciting and an interesting conversation to talk about sort of the progress that's been made in medical science with DNA. So, and like what the unmapping or the mapping of the human genome did for people. I might watch some other stuff by Francis Collins too. He's a very influential guy. He was the head of the National Institute of Health for like many years under Republicans, Democrats, and also happens to be a believer, which is kind of interesting. And he wrote this book called The Language of God, which was highly influential on me as a young 20, well, I guess 30 something at the time that came out. So I guess not so young, but it was an influential book, and he's a really brilliant guy, and so worth kind of listening to and checking out. So I might kind of live comment on that. It may not be quite as rowdy as some of the streams earlier today, where we were joined by so many people. But we're gonna go from like about 12 to, let's see, probably about 2. All right, so I have my setup here. I'm going to be working off stream, and we'll go ahead and get our view. Hopefully that's decent. And this will be just kind of a commentary view where we can kind of look at what's going on the video and kind of comment on it. And let's see here. I'm still kind of working out this setup, but I think this works pretty nicely. I'll kind of scoot over a little bit so there's a little more room for the video. And we're going to get into it. So here we go, ladies and gentlemen. Hopefully the audio is okay. So let's find out. I'll go ahead and press play.
Good afternoon, everyone. Welcome back. We hope you enjoyed.
And hopefully that's coming through. So if you're watching, just let me know if you can hear it.
My name is Christina Capesti, and I am Chief of the Policy and Program Analysis Branch at NHGRI. And I'm pleased to bring this amazing symposium to a close with today's Louise M. Slaughter National DNA Day lecture.
Let's pause here. So I think this was a congresswoman named Louise M. Slaughter, but I just think it's pretty badass to have Slaughter as your last name, especially if you're a politician. I know she was very important for the DNA research thing, so I don't want to meme too much about it, but I'm just saying it's pretty cool to have the last name Slaughter. Coming from like a G.I. Joe loving background, you gotta appreciate, or if you're into, old school 80s wrestling, like Slaughter's a pretty good last name is all I have to say. Okay, let's continue.
This lecture is named after Congresswoman Louise Slaughter, who in 2003 led a group of legislators to pass a concurrent resolution creating National DNA Day to celebrate the completion of the Human Genome Project and the 50th anniversary of the discovery of DNA's double helix structure.
Yeah, double helix. Let's see here. Okay, I have all my setup. I was going to pause for a second. I will let you guys know, like I said, I'm going to be working on comics. That's the whole goal of these streams, is to kind of work on some art and stuff. So while it might be off screen, just know like I'm plugging away as this video plays. So if I do kind of, wane off, or like kind of my brain kind of gets a little distracted, understand off screen I'm working on art stuff too. No, I do not want to update okay. My computer was like, you need to update. I'm like, not yet. Okay, continue.
Representative Slaughter passed away in 2018 after a barrier-breaking career dedicated to science and public service. She was one of the earliest champions of genomics on Capitol Hill and a steadfast advocate for policies that allowed genomics research to advance to the point it is today. It is also...
So Christopher Runciman recently did a one-page comic called The Gnome Genome. Part of why I had recommended it in his live stream, and part of why was I was listening to a thing on the human genome, and I just thought it was funny. The idea of genome sounds a lot like gnome, so I was just like, that would be a funny wordplay, and that's why I kind of recommended it. And the great thing about Christopher, who was on the stream a little earlier, I guess yesterday now, since we're about into midnight, was that he actually took that silly idea and made it into a comic. And if you're curious about that, you should check out Christopher Runciman's channel. But yeah, let's see here. Let's continue. We should continue. Okay.
Thanks to her that we now have a law called the Genetic Information Non-Discrimination Act.
This is a huge law
that prohibits genetic discrimination and whose protections allow patients and research participants to undergo genetic testing without fear that their results will be used to negatively impact their job
It's kind of a
or
big
access
deal.
to health insurance. To bring us full circle on this DNA Day, our next speaker worked closely with Mrs. Slaughter on Gina for years, literally years. Until recently, he was the director of the National Institutes of Health and previously directed the National Human Genome Research Institute. It is my privilege to introduce a man who needs no introduction, if there is any DNA in the room, Dr. Francis Collins.
So here's the thing I also find refreshing about Francis Collins is quite often, like, at least in the last few years, I'm just going to be, fully transparent. It can be really depressing to actually be a Christian at this point in time. And this is no knock on anyone in particular, but I'm just talking about my own personal experience. It's been really disheartening in the last few years, being like a kind of thinking Christian and realizing that like 90% of people that profess to believe what I believe, I shouldn't say 90, but like a good chunk, are sort of like not fans of science and also are not okay with truth. And it's very frustrating for me. It's always been very frustrating because I came to belief as a from atheism and like being a pretty hardcore atheist. And it's kind of bizarre for me, having come from that background, to kind of find this very meaningful faith for myself, to like kind of look around at people who are professing to like follow Christ, and are like so hesitant to talk about truth or talk about or like explore truth or learn truth. And it's like the whole idea of the truth shall set you free is like a biblical idea. It's just a strange thing to kind of run from truth, when yeah, I mean, when like the whole idea supposedly in Christianity is to like kind of lean into the truth, and like it's actually part of the armor of God or whatever. So it's been especially in the last year, where there's a lot of science denialism and like sort of anti-elitism that leads to a lot of kind of like anti-academia kind of things, and not just anti-academic when it comes to things like science, but like anti-academic when it comes to like poetry or art or music. And I'm seeing people become like kind of like the 1980s like satanic panic thing, which to me is just like a cartoon version of what I believe, and is relatively frustrating and also feels like a scam. And so that's not to trash anyone who's maybe stuck in that system. It's just it's been disheartening. And so for me, people like Francis Collins are very encouraging, because it's like a good example of a rational Christian. It's like a C.S. Lewis types are still out there. And so I take a lot of hope and encouragement from that, including also by people like my friend Alan Noble, who's like a really brilliant writer. And he just recently wrote On Getting Out of Bed, which I highly recommend people check out. But as like people like him, people like Francis Collins kind of give me hope that there is hope. And that we're not just surrounded by like kind of, I don't know. Anyhow, let's continue. But I just wanted to put my cards on the table as to why I like Francis Collins so much. Adam Lohr said, "The Language of God is great." I agree. It's a wonderful book. And also, he's like a brilliant guy. I mean, the dude literally. Yeah. Anyhow, well, you'll see what he did in this lecture. This is kind of a walkthrough of the breakthroughs of science and DNA and the explorations of DNA, and how that has led to so many positive things in the world. And when you see it in a scope like this, and I'll disclose, I've seen this lecture before, but when you see it in a scope like this, it just really is like, it's almost like looking at the universe. Like you go outside and you look at the stars, and it's like this very beautiful experience of like going out, checking out like a beautiful night sky, But then when you start looking deeper and you look at like all the intricacies and details of like what composes these little light dots that you're seeing that are beautiful in the sky, it becomes more beautiful, but also really daunting and overwhelming, right? It's kind of like that. Like you're seeing all these different data points for like the progress of this crazy experiment that people made trying to map the human genome, and then why that was so important. And it's, especially this day and age, I think it's really important for people to check out and understand. Um, Adam said, "Do you mention Collins in Two Stories Book 2?" 100% do. He was one of many. I feel like what changed my mind on my faith to kind of actually approach Christianity, one of the people was Francis Collins. He was a huge part of that. But it was also the friend who lent me the book. It was a lot of different thinkers. It was definitely C.S. Lewis as well, which actually compelled Francis Collins. It was there were a lot of like kind of huge people, and actually it's funny, we've watched now I'm blanking out, John Lennox. We've watched him on here, and he's a guy who convinced me a little bit without me realizing it by watching debates with Lennox versus Hitchens. And I loved Hitchens, and I would see Hitchens just bury people. This is like back when like the New Atheists was like a big thing, and I would see Hitchens just demolish people, but I'd see Lennox, and it's like weird. He'd like hold up, and then I saw Lennox. There's a really famous debate between Lennox and Dawkins, where Dawkins just gets like eaten alive. And it was kind of shocking to me because I was like, wait a minute, that's not like you can't be like an Oxford mathematician and actually believe this nonsense kind of thing. And then my mind started changing gradually. What ultimately changed my mind was, putting to the test like the basic stuff. But let's see here. I'm getting a message. Nice. Okay. But anyhow, like again, like Collins is just really it's just inspiring and encouraging to know that there are people like that out there. I'm also trying to. Okay, let's see here. Again, I'm doing layout and stuff, and it's like a lot of that's like making sure costumes are right, making sure like all my ducks are in a row. and I wanted to make sure. Okay, I've got that set. Okay, and let's continue. So here is more about DNA. Let's go on this journey. We've talked about on here. We watched a lecture on like the neutrino in general, and just I thought I did a really good job of explaining why I'm like so fascinated by neutrinos. Again, I'm not a scientist. I'm just an art guy, right? Like I'm working on a comic as I'm commenting on this stuff. But science is fascinating, and this hopefully will inspire you guys. It's just super inspiring. Somebody dedicating their life's work to trying to help people, help cure diseases, and help people live longer. And the inspiration and the drive of Collins, if regardless of what you believe, should be really inspiring for a life well lived, like dedicating your life to trying to do something good. And I think that's pretty noble, and also again humbling too, because like when I'm working on comics, it's easy for me to feel like, oh man, like this is a struggle and stuff like that. And I have to remember there's guys like struggling out there to like decode the human genome so they can help people with like these incurable diseases. It's like, so the stakes of what I'm doing are not nearly as monumental as the stakes of this kind of thing. Nice. Adam said, applying some hand anatomy studies to some moon wizard drawings. Nice. And I have to say, Adam, I still love just the fact that you're drawing a moon wizard. That makes me happy.
Okay.
By the way,
good afternoon, everybody.
I should let you guys know where you can find this. So this is on the National Human Genome Research Institute's website. and it's the 2023 Louise M. Slaughter National DNA Day Lecture. They do this every year. And this one's a really good one. It's nice that they had him as like the key speaker here. But like, it's funny, among DNA researchers, like Collins would be like up there as a rock star.
I want to have the opportunity in this last hour, or maybe a little less than that, of today's remarkable symposium to talk a bit about my own sort of view of the long sweep of why we're here and what exactly has transpired over these 70 years.
70
First of all, I want
years
to say thanks to all
recapped
those
right
who
here.
worked really hard to put this together. This was a big event. All of the many people who had to assemble the various components to make this happen because Eric Green told them to. And when Eric says do something, you do it. By the way, I'm planning to be gracious about having won the competition, so I'm not going to rub his nose in it. It was a good.
Adam was saying he has such an
competition,
animated
even though
voice.
some
Yes.
of the things in that video I think were rigged. Ask Eric to play the piano sometime and see what happens. Just say it. But no, there was a huge amount of effort that went into this. People like Sarah Bates and many others who put heart and soul into making this the most amazing day of April 25th that we've had in a very long time.
Yeah, he does sound like a
kind
cartoon voice actor a little bit.
Give you a bit of a perspective about the last 70 years. I do want to give a shout out, as was already done, to Louise Slaughter because of the fact that she made major contributions to the fact that DNA can now be utilized for your own health without.
Oh, let me chime in here too. One thing I also found really encouraging about this lecture is it's really easy to kind of get it's really easy to kind of like look at like government and look at all these things and just see all the corruption or all the horrible things. This lecture kind of talks about some of the effective things that happened with legislation in regards to like human rights and DNA. And it's kind of interesting because you see this like behind the scenes, like collaborating and kind of fighting together for the good of humanity. Within the system, right? And it's like, so there are good people within the system. I'm not saying everybody, but I'm just saying like it's encouraging to see that like even this representative, it's like I don't even know what political side of the aisle she was on. Like honestly, I'm too unaware of that end of politics. But I think that it's just an interesting kind of window into like seeing like not everything's like corrupt and crazy, and even through all the like logistics and red tape and stuff, amazing things can happen. Okay, let's continue.
Fears of having it used against you, and I'll come to a bit more about that. She was a colleague and a good friend, and sorry we lost her 5 years ago, but she played a huge role in a major component of what the Genome Project was able to do in the public policy arena.
All right.
So this is what DNA means to you. Have a look at that picture for a moment. This is how it works. Mom and dad get together and they have a baby, and baby gets half of mom and half of dad. That was what seemed to happen on this boardwalk anyway. Well, let's get a little bit more into the molecular biology than that. It is, of course, that double helix. And it is, of course, the 70th anniversary of April 25th, 1953. So let's take it a little trip on our time machine. Imagine that you are somebody walking around right then. What would you be using for social media? Well, kind of stuff like this, radio, maybe a little bit of a TV that's about the size of your phone. TV Guide had just been introduced. It was a really big deal.
You guys remember TV Guide?
These days. That's what people were paying attention to. And unknown to them, somewhere in the United Kingdom, an insight had happened. Right? And it was April 25th in the journal Nature, where that insight was published, including that diagram you see there of the double helix, which, by the way, that is a right-handed helix. I hope none of you will ever make the mistake when you're drawing DNA to accidentally make a left-handed helix, because if you do, you'll end up on the wall of shame.
You know what's funny? So this whole point where he's saying, hey, it's a right-handed helix. It's funny because the next day at work, there was a client that sent in a logo of some kind at my day job that had DNA on it, and it was like a research institute or something like big that actually works with like DNA. And I realized they drew the helix wrong, which again, it's their logo. So what? I'm not gonna say it. I'm not gonna tell them like, you know, this logo that is probably like branded on your building to like represent science is like the wrong sided helix. I thought that was funny. The problem is also I will probably forget whether it was right or left about 20 minutes after this lecture.
On the internet. And there's an awful lot of people on the wall of shame who maybe should have known that. By the way, my tie, 1/3 of it is on the wall of shame. And you will see there are 3 different renditions of DNA here. That one is right-handed. That one is right-handed, but this guy in the middle is left-handed. I had to tell you so you wouldn't come up later and say, did you know? It's still a really nice tie. And since people were showing off their scarves and their socks this morning, I had to point this out.
Okay, come on, guys. Let's enjoy the fact that there's somebody whose day job has a wall of shame and to get a massive kick out of wrongly drawn DNA. Like, come on, that's beautiful. That's beautiful. The fact that like he's among a bunch of like geneticists, and so he's like, hey guys, I'm heading this off, okay? One of these helixes is facing the wrong direction. I had to say it so I don't get bothered. And I just imagine this room full of people who are like, hey, Mr. Collins, or Dr. Collins, your helix. Yeah, I mean, that's unforgivable. It's great. It's like, I don't know, it's beautiful. It makes me feel less bad about being so like niched down in like our conversations about comics. Hey, everybody's a geek about what they do, okay? In a good way. But I love that there's people who are like hardcore in this space. All right, let's continue.
So it was
Adam, wall of shame. It's amazing.
When this double helical structure was published, you can see the photograph of Watson and Crick pointing to the model that they had built, showing how those bases paired with each other, spinning around this central axis in this beautiful, remarkable, most amazing molecule ever, deoxyribonucleic acid. But there's another part of this story that we should not just gloss over, and that is their ability to put together this structure depended upon seeing some experimental data. And it was not data that they had generated. It was data generated by this person, Rosalind Franklin, and it was that particular picture you see there, plate 51, which in her efforts to try to do X-ray crystallography of DNA, she had obtained this. And it was that particular pattern, which seen by Watson, was recognized as pointing to this being a double helix and led to their changing their plan about how to put together the models and coming up with what we now know is the right answer. So whenever we talk about DNA and we talk about Watson and Crick, and we should also talk about Rosalind Franklin. She did the work. Sadly, she lost her life to ovarian cancer, maybe because of the radiation she was exposed to as part of her job before the Nobel Prize was awarded.
That's one of the crazy things about
Watson and Crick.
Let me pause this. One of the crazy things about a lot of scientists at that era, a lot of them did like die because of radiation that they'd use in experiments. And it's kind of also interesting to think, like, you know, when you're in school and stuff and you're hearing like Watson and Crick, like there's a whole bunch of people and researchers behind that. It's not just that one person. It's easy for us to have this like myopic view of science, like, you know, and it's kind of cool that it's a little richer than that. Like there's, you know, it's kind of a human effort, for better or worse, you know. All right, let's continue. Also, just that picture. Sorry, I want to pause and appreciate that picture of Rosalind Franklin. That's awesome. I want to draw that for a comic book. It's just rad. Okay, let's continue.
And one other fellow in 1962. But let's always, and whenever we talk about DNA, think about Rosalind. Well, I didn't know that was going on. I was actually 3 years old when that announcement was made, and nobody told me. And this is me about age 7 or 8, I guess. This is where I grew up, on a farm about 2.5 hours from here in the Shenandoah Valley. did not have indoor plumbing, just in case you're wondering. This was a fairly austere kind of way to have your first 10 or 12 years, but it was also wonderful because my parents were really into the arts and theater and founded a theater in the Oak Grove up above our farmhouse that is still, I think this year is its 70th consecutive season. So I was surrounded by lots of exciting people in arts and music and theater, not at all in science. That came along later in a wonderful high school chemistry class taught by a very gifted teacher who made me realize that science is really cool because it's basically a detective work. You're trying to figure out answers using clues, and some of them are wrong and some of them are right, and eventually you figured out what happened. So that was 1953. It's not the only thing that happened in 19.
Sorry, that's such a good description of science. Like, I think, because it is kind of detective work. I wish, I don't know if you guys had this, but I feel like I probably didn't have the best science teachers. Because like I didn't actually get like seriously interested in anything scientific till much older. Even in college, like looking at microscopes and stuff like that, like I just kind of do the lab work or whatever that we had to do for our homework. I didn't really experience like the wonder of it until much later, just in kind of exploring it and being interested in it. Now, am I a scientist? No, but like if I were to have the opportunity to have like a science class now, I think I'd actually find it really much more intriguing, even though I'm sure it's still hard and would be a headache to do assignments and all of that stuff. I think kind of similar to like art was hard as hell, like in classes, like taking art classes, learning anatomy, like doing life drawing. All of these things were really challenging and hard, but like I wanted to because art's cool, right? Like art is really interesting. It's something I love doing. And I do kind of feel like given a second approach, if I ever had to like take those classes again, I have a feeling I wouldn't hate them as much as I did at the time, because it's just like I kind of get it a little more, not entirely, but I at least understand like the function and the purpose of it, and maybe that's not bad teachers, but I feel like I didn't have a teacher that like kind of inspired me with that kind of stuff. Similarly with math, like Benji's approach to math right now, like I think part of why my son is super into math is like the way they teach math nowadays, although it's confusing, for those of us who learned it like rote, like all a lot of us, like, when we were kids, is like you just kind of did flashcards and like memorized crap. Like, and it's like you don't need to know why, you just do it. And it's like, whereas now the approach to math is really fascinating because they kind of teach kids that there's like 50 ways to like come to the same conclusion. Like, hey, there's 10 ways we can do this addition or multiplication issue problem, and like, and here's like a grid, and we're going to have you do all the different creative ways, or we're going to have you do like some like a mathematical equation, and then here's the section where you can explain how you did that and like what you used, what system did you use to kind of come up with that answer. There's multiple systems, and like that more kind of creative approach to math, I think engages a mind of somebody like my son who's like really creative. For me, like growing up, when it's like rote learning stuff was like boring as hell. Like memorizing dates and names with history instead of actual events, and stuff like that just never really resonated with me. But like the newer approach to that, I think is really exciting. And now I'm on a tangent. Let's get back to Francis Collins' lecture.
53. We have some other anniversaries to celebrate, so let's give them credit too. The Corvette TV Guide, I mentioned already, means a lot now. Cheese Whiz.
Hey, Cheese Whiz, don't knock Cheese Whiz, man.
Product, but it's still there.
Don't knock it, Francis.
Peeps, when you have those that you put in your shelf and let them dry out, well, they got started in.
Am I crazy for being somebody who actually really enjoyed Cheese Whiz? I mean, not the little crusty part that would be at the top. You'd have to pull that out. But like everything else about Cheese Whiz when I was a kid was amazing. Probably would make me sick, but still, a soft spot in my heart for Cheese Whiz.
1953 also. It was the first to send them out Everest. Okay, that's pretty significant. But I still think, look at that list. what really happened that mattered here. It's that last one.
Yeah,
So that
that's right,
was
Vic. Don't disrespect the
1953.
cheese
Now here
whiz,
we are
Francis.
in 2023 with a whole lot of amazing things that have happened about that double helix since. So what happened in between? We learned a
Ooh,
lot about.
let's pause here and just note like how significant him. Like, it's a very smart move for him during a lecture to kind of connect it to things that were happening at the time, because he's kind of right in the sense of like people may not have even known it at the time, but it's like scientifically, like that was like, it's hard to think of something that's that important. Like, it really is, like, just, and he'll get into why, but I mean, I think it's pretty obvious nowadays, this day and age, that like DNA and like the structure of DNA and like figuring that out is a huge scientific breakthrough. Like, it unlocked so much. It's just kind of unbelievable. Oh, nice. Nice. Adam Laura said, all up in the cheese whizzes, don't even know the flavor. Damn right.
How this molecule does what it does, although we are still learning. This is still my favorite picture, although it's old, because it really shows you
That is
the
a
way
cool
in which
picture.
DNA is kind of wrapped up inside the nucleus and then rolled out there to show the base pairing, A match with T and G with C. And all living organisms use this same way of coding information and passing it from generation to generation. It's in the visual arts, like in my tie. Lots of things here that you see DNA around you no matter where you go. My 18-year-old grandson will be getting his DNA tattoo on his torso in about a month, and it better be a right-handed helix.
I'm sorry, how cool is that his grandson's getting a DNA tattoo? Like, I feel like Francis Collins would be a cool dude to hang out with. I'm just saying. Dude plays guitar. His grandson's rocking a DNA tattoo. It's like, these are my people. I feel like these would be my people. They'd probably make fun of my inherent like utter lack of understanding of science, but still. Oh, Vic Dew said Gold Key appeared to have closed their submissions uh, after backlash for the 200 pages thing. Interesting. I'm sure they'll just rewrite it. I mean, it's a new thing. I think part of why they were saying 200 pages was they want people to have stuff ready to go. Adam said, nice tattoo, son, but I have to add you to the wall of shame for the left-handed double helix. Exactly. Nice.
But let's look at the timeline here.
That would be
It's a wonderful
hilarious.
diagram that was made by, I think, by Daryl Leja a long time ago that basically shows you some of the main things that happened going back to Mendel. And of course, Watson and Crick came along as part of that. It was only 1944 where people had evidence that DNA was the hereditary material. So that's where they fell in there. But then, of course, how does that work? How does this instruction book actually turn into some action? Right here in this very space, you should look as you go out, if you haven't looked at it already, at the display on Marshall Nierenberg, which is out here, because Nierenberg here at NIH figured out how DNA goes to RNA and how then RNA goes to protein. That genetic code, recombinant DNA came along, the Belmont report about human subjects, and then a whole lot of other things over the course of the next few years. And I think it would be fair to say, if you were a scientist, as I was in the 1980s, interested in trying to track down the causes of a human genetic disease, you're going to have a really hard time. There was no genome to work with. You could get little bits and pieces of it. If you worked really hard, you could read out maybe 100 letters of a DNA code in an afternoon. That was kind of it. And if you wanted to actually find a disease gene, which you didn't know where it was, somewhere in that 3 billion base pair genome, you had no signpost really to guide you, and you didn't have much in the way of computational assistance, and it was hard. So for instance, a search for something like cystic fibrosis, which really got started in a pretty significant way in 1982, took 7 years before it finally found the answer. And as I was part of that, I had to explain why it was so hard. And so I had to have a picture of myself taken in a Michigan haystack holding up a needle saying, this is why it's so hard. We're trying to find a needle in the haystack. The needle, in the case of cystic fibrosis, just 3 letters, a CTT, that was missing from an exon of a gene that nobody had ever really paid attention to before. And that was an answer that then found its way into a publication. But it was so hard to do that. You could imagine how difficult it would be.
Sorry, I got to pause here. How badass is that magazine cover? Sorry. The content's amazing. They're talking about, discovering the sequence for cystic fibrosis and like the misspelled letters of DNA that cause that, which is like a huge deal. But also I'm a visual artist and I'm like, dude, look at that science magazine. That's badass. I want to stay on pause for like a few seconds so my fellow peeps who do visual art can just appreciate. Look at that design. That is awesome. Okay. Anyhow, sorry. That's rad. It's like the gradient, the lines, the placement. That's a great design. Really love it. And look at just the typography on science. How pretty is that? That I lining up, like the dot of the lowercase I lining up with like the top line of the S. Ah, oh, so pretty. What is this? Vic said, "When's Josh doing an homage cover to this magazine?" Dude, I might rip that idea. Look at that layout, man. Look at that beautiful layout. All right, let's continue.
Thousands of diseases. So we had to have a better plan. And meanwhile, that plan was being very much thought about and put together. And this was a particularly important document from the National Academy of Sciences with a very distinguished group of senior scientists, some of whom had been pretty opposed to the idea of doing the Human Genome Project, but came around in the course of these debates and very reasonably put out a plan, which was not that you just start sequencing human DNA on day one, but you're going to have to get the technology a whole lot better because it's not up to the task. And you should start with other genomes that aren't quite so big, but which are also going to be really interesting in order to build up your capabilities. So start with bacteria and yeast. And let's do that roundworm, which is so important. And all of that built the interest.
Sorry, again, like just visualize that being your day job. It's like, dude, we need to decode the human genome. And it's like, yeah, but like let's start with something like bacteria and yeast. Like that's something you're hearing at your day job. Let's slow your roll. Okay, let's start with bacteria and yeast. All right. We're not going to go like full bore, dive into the human stuff, just some bacteria and yeast. And then he goes home, like, to his wife, like all pissed off. Like, I wanted to just jump into the human genome with the person. No, sorry. And they're giving me bacteria and yeast. Anyhow, let's continue.
Interest of a lot of people to come alongside and join this effort. And it was almost exactly 30 years ago that I left my position at the University of Michigan with my heart in my throat to come and be a federal employee and to manage the NIH part of the Human Genome Project, which ultimately became the lead in this effort. And an amazing ride it was, indeed. The first few years, we worked on those model organisms. We worked on building maps, both physical maps and genetic maps of the human genome. I want to highlight, though, some really important things that happened that weren't just about sequencing or technology, and that was about the principles we were going to follow. And particularly down there in the lower right corner, in 1996, we had to make a decision about exactly what to do with the data that was being generated. Because we knew this project, which wasn't supposed to be done until 2005, wasn't going to have a big publication to describe the nature of the data that was being generated. And yet people were interested in the data as it was coming out, even though it was fragmentary and it hadn't been assembled. If you were working on a particular gene and the Genome Project had just produced some sequence data, you wanted to see it.
Did he say...
So a group got together, and it sounds...
Did he say fragmentary? Is that a word? Wait, I gotta back it up. I'm sorry, guys. This is crazy, but I'm like, is fragmentary a word? And did I mishear that? Let's look it up. Hold on, let me save what I got here. Am I crazy that I didn't know that word? It's funny. I was like, I've been listening to like a lot of weird philosophy and stuff like that, and I don't come across words like that that just really stand out. Fragmentary. Oh, it's fragmentary. Okay. But why would you say fragmentary? Okay, let me back up. Hold on. Hold on, let me see. Maybe it's a name because Adam was saying Dan Fragmentary. Okay. Because I thought he was saying fragmentary as like a term. Okay, let's rehear this. Maybe I misheard it.
To describe the nature of the data that was being generated. And yet people were interested in the data as it was coming out, even though it was fragmentary and it hadn't been assembled.
Oh my gosh. I'm sorry, you guys. Francis Collins, one of the most brilliant brilliant, literal genius. So I can't knock him. I mispronounced so many words, but I got you. I'm on you, Francis. I know you use fragmentary. Okay, guys. Sorry for this fragmentary version of commentary. I will continue. If you pronounce things weird, you seem smarter, Vic said. Well, in that case, dude, I pronounce things weird all the time, so I must be some kind of genius. All right, let's continue.
Assembled. If you were working on a particular gene and the genome
Sorry,
project
Francis,
just
you're
produced
awesome.
some sequence data, you wanted to see it. And so a group got together, and it sounds very lovely in Bermuda. I don't remember anything except the conference room. And we really had it out here about what is going to be the data access and release policy. And to the credit, I think, of the group that you see there, a remarkably hard-driving set of scientists who are all pretty competitive with each other, they decided, no, this time the right thing to do is to just make all this information available.
Oh, nice. Okay, I didn't make the Dan Fraga connection. Okay, that now I'm getting it. That makes a lot of sense. Dan Fraga. Oh man, fragmentary. Let's go.
See there, the whiteboard, that's the handwriting of the late John Sulston, who got up at the board to sort of put down the comments of what the decision would be. And you will see automatic release of sequence assemblies greater than 1 kilobase, preferably daily, and then immediate submission of finished annotated sequence. And that's what we all committed to. The representatives there from 6 countries, some of whom realized they had no authority to make that commitment, but they did it anyway. And that has become really the norm for genome science. That if you're going to do a large, complicated, community beneficial project, then the community needs to benefit by having access to the data.
That's awesome.
It's pretty transformative. That had really not been done until this decision was made.
So I don't know if you guys know like the weight of that, but it's like, imagine, like you see this quite often in science where some stuff is like kind of kept secret, or it's like not just kept secret, but it's like, it's considered like information that's only disclosed to maybe like a specific patent or something like that can have the exclusive right to use the technology or the data that's gleaned from like a scientific process in order to sell a product or make innovations. And that can be really good in a weird way to like compensate the companies that are putting in the money for research, but on a governmental level that's like really dangerous because again, like you need to kind of share that information in order to kind of expand your base. Vic said, I never think of Josh as somebody who would know Extreme Studios stuff. If you give me more Fantagraphics vibes. Yeah, I mean, here's the thing. I got into Fantagraphics later. I started on all the image stuff, all the image boom stuff. That was like my 7th grade self was like all about Spawn. I would have been like, you gotta listen to Spawn when he's fighting Violator, and like I would have been all about that. Without that accent. I don't know why I throw in that accent every time I talk about my past or junior high. Adam said, I think Josh had said he was really into Spawn and Sam Keith and stuff like that back in the day. I'm still into Sam Keith to this day. I think Sam Keith was probably of that bunch, of that group of image artists. I'd say him and Now I'm blanking out. Savage Dragon. Like those were the two, like the Max and the Savage Dragon were probably the two most sophisticated comics coming out of that group. And the Max, like, still to this day is just it's weird. It doesn't have a fully resolved ending, but it's like such a fun just exploration of like art and life and philosophy. It's a great series, man. Let's continue. Vic said no more love for Spawn. Nah, I mean, Spawn's deep in my heart, you know? Like I Todd McFarlane, when I was in junior high, Todd McFarlane was the epitome of what I wanted to do and be and read. I was a Spider-Man kid, and so I was really into anything Spider-Man, but particularly I used to follow Web of Spider-Man, which is unfortunate because it wasn't like the McFarlane run, but because McFarlane was on a different Spider-Man title. But dude, when McFarlane was working on Amazing, I mean, there was no better at least at the age I was at. I just thought he was the best Spider-Man artist who ever lived. I put him above like every single, to now, obviously my opinions have changed and there's many more artists that were far better in my opinion, working on Spider-Man. But at that time I thought this guy, not Ditko, right? This guy is the best artist. And I wasn't alone. Like a lot of people, man, he was doing some really crazy innovative stuff, especially with cover work. Like the way that he would draw like every little like weird notch and bubble and stuff in the like whatever those things are, he'd draw like webs in the coolest way. He had like a really good balance of black and white. He had these really exaggerated figures. It's just so exciting. Yeah, and then Vic Du said, I'm a decent Eric Larson fan, but sometimes the power that be over Silverline got beef. I have no idea what that means. I'm sorry. Yeah, but so I'll say, like, I still have a love for Spawn. I actually think, like, if my son's, like, in, when he gets into, like, 7th grade, I might be like, dude, and I might hand him, like, the 60 issues of Spawn. Because I think I followed it for about 60 to 70 issues, and I literally bought every single one from, like, when Greg Capullo, took it over. And so it was like that whole arc, like, and I used to even be so obsessed with Spawn that I would buy any comic that had Spawn in it, which was possible back in the day. He'd guest appear in a bunch of different comics as a character, and I would just pick up a comic. Like, I was so into Spawn that it didn't even matter if it was a comic I wasn't following. I'm like, Spawn's in this, bought, so anyhow, yeah, let's continue. Oh yeah. He said a friend has personal beef with Larson. And then Adam said, "Did you ever ask Roland if he remembers working with Jeff Lafferty?" Oh, was it what is it? Pumpkin. I'm blanking out. You guys can let me know. But Jeff did work on oh my gosh. Now I'm blanking out. Oh well. Let's watch more DNA stuff. I will remember the comic you're referencing though. Maybe you'll mention it in the comments. Okay.
So it's worth highlighting a bit. Things got a little complicated after that. There was a private sector enterprise that said, hey, we'll take it from here. The government effort doesn't need to continue, or maybe they should just sequence the mouse because we'll take care of the human. Suddenly the people got interested about the Genome Project because now, it was contentious. There was a battle going on, and who has a yacht and who has a motorcycle suddenly became important. And it was a little unseemly, actually, from time to time. And fortunately, it was possible, and there's a whole story about how that came to be, to basically declare a truce and to say, let's celebrate that we are actually, by June of 2000, in the position of saying we have a pretty good draft of the human genome. And that is what happened June the 26th in the East Room of the White House, where President Clinton pointing.
So let me pause here. I'm going to highlight something here for people who get all weird and partisan about science. Um, like scientists, at least like, at the NIH and stuff, most of these people are not like political, like or maybe they are, but like they serve under multiple presidents and multiple administrations. So I want to highlight that, like right now he's mentioning Clinton. I just want you guys to know that like right after Clinton, it's like Bush, right? My point is, it it's really frustrating sometimes to hear people be like, "Oh, this person's just a left leaning, blah blah blah," and it's like, I've heard that leveled at Collins, and I think from what I've read of Collins, he might even be more right leaning with certain things. He's left leaning with certain things and right leaning with certain things, but he's kind of an apolitical guy. And it always frustrates me when people in politics or people who are obsessed with politics and view everything from the lens of like left versus right and stuff like that can't just understand that like a lot of the time these people are not like subservient to like one party because they outlast they outlast most of the parties. They're just kind of in labs being geeks, in a good way. Um, let's see. Vic said they are, but their politics have both to do with their job. But yeah, but here's the thing. So imagine, and this is just a thing to like, just think about the reality of it, right? Like, so if you're the head of NIH, right, and you need funding, you're going to have to like work with senators and congressmen on all sides of the aisle, right? Because you need that money. You can't be partisan. You literally can't because you won't get funding. So like it just the notion that like this agency would be like, it's a big left leaning agency. No, because if it were a left leaning agency, then anytime the government kind of switched towards the right, which it will in the lifetime of that agency, it would just get defunded. It's like you kind of, I don't know, it's a thing to think about. Like they actually have to be more kind of apolitical due to just a requirement, right? It's an interesting thing. Oh, Vic said it was supposed to be nothing instead of both. Yeah, exactly. And it's weird because politics do influence their job in the sense of like political jargon, like can affect the process of this stuff. But the point being, it's just, I don't know. It's anyhow, it's just a good point to bring up. And you'll notice this with Colin's career. You're going to see different presidents that you might agree with, you might disagree with, and I think that's honorable.
Out that was the very room where Lewis and Clark had unfolded their map of the western part of the United States. We're unfolding another map, he said, the most important, most wondrous map ever produced by humankind. It seemed pretty over the top at the time, but looking back, I'm not sure that that's over the top at all. This is an amazing map, not just about something else, but about us. At the same time, there was no publication. John Sulston said, we're all just a bunch of phonies being here making an announcement about this because we haven't really hit any particularly measurable milestone. We're probably about 90% coverage in this draft, which is not very fully assembled yet. And we just decided to say we did it. But it was important to say because it really did turn a corner. But we couldn't stop there. We had to have some deep analysis of what this all meant. And the next several months were deeply engaged in that. And that then led to, in 2001, the publication in Science and in Nature, back-to-back, of versions of the human genome. You saw Joni Rutter waving her own copies around this morning. And I have copies of this also that I keep rather carefully. If you go, actually, oddly enough, my copy of Nature that has that is currently in an exhibit in the Museum of the Bible downtown, if you're interested in seeing where that is. So that Nature issue, by the way, we worked hard on the artistry there of what should that look like. It's got to be the double helix, but how do you make that pattern? And yes, it's a mosaic of people's images.
I want to pause here. I've never been to the museum. I don't really know what I think about the museum, but the Museum of the Bible, if you're ever bored and you want to see like a really brilliant logo design, check it out. It's shocking. They just basically took a capital B like this and just converted it so it looks like a book. It's one of the most like I have had to do work with that company and the first time I saw that logo, I was like, oh my gosh, like it kills me. And yeah, if you're bored, look up the Museum of the Bible logo. That's graphic design. Okay, let's continue.
And we had a little fun burying a few secrets in there if you look very carefully. Watson and Crick are down there in that part. And Rosalind Franklin, unfortunately, at that point was not. And I've always regret that. So what did we do? We had a party. We published the first draft. We analysis of it.
Science
A lot of
parties, you
surprises.
guys.
And we got to have a celebration. And where is this? This is the National Building Museum in Washington, D.C., which is a pretty elegant space, much more elegant than most scientists have generally been invited to run the show for. And we had a band. Yes, of course, there's always got to be music. So we were, in that case, putting forward some songs written for the occasion. And people were having a pretty darn good time. We worked really hard to get to this point. My mother came, that's her in the red. And you can see there's Eric looking a little younger and me looking quite a bit younger, and Barb Biesiker over there. And I'm not sure who is pointing at me. It might be Gabby. I thought it's Eric's wife. And yeah, we are right now dredging up more of these photos, and it is kind of fun to look back on. So this is 2001. But that was still not the completion of the Human Genome Project. We had to finish, as best we could in those days, all of those chromosomes that still had gaps. And that was another very tough set of a couple of years of hard work.
Vic said that is so brilliantly simple. Nice.
And it's like every other project, the last 5% takes you half the time. And there was a lot of that, but people stuck to it. And you couldn't have any chromosomes that were like, sorry, not quite as good over here. Everything had to get done. So the genome centers had to agree to kind of share the effort. Meanwhile, people were having fun.
And I think that was in regards to like the Museum of the Bible logo. Yeah, it's like, again, like, I don't even know if I like the Museum of the Bible because I've never been there, but it's like the logo, dude. Like, that's, tip of the hat to the graphic designer who came up with that, because I was like, I don't know if I'd come up with that solution. It was so good. It's just, kills me. Okay. Oh, he's calling out an Onion article
about how hard this was. I don't know why the Onion decided that this was a story. Yeah, the Onion picks this picture of Bob Waterston, who is running the Genome Center at Washington University in St. Louis. Gives him somebody else's name, Farian, and then recaptions his poster a little bit to just say, what the hell? And he's actually showing a diagram of a chromosome. Yeah, this is like, okay. And read the story here. The National Science Foundation has had their big symposium. They have reached the consensus that science is hard. Well, we kind of knew that already. Anyway. I still would love to know who came up with that.
That is a funny one.
So yes, we had to
I loved the Onion back then.
Version of the human genome sequence with all of the closures that we could do at that point. Obviously, Adam Philippi has come along and finished really, and I'll mention that in a minute, the genome. But at the time we had the technology we had, that was it. So we had another party. This is the Library of Congress. I love
that his recap is most of the parties they had, but it's kind of neat because it's like they're celebrating a lot of work.
ACTG, isn't that clever? A celebration of the genome.
That's clever, but that's an ugly logo, Francis.
That was exactly 20 years ago. Hence the reason for calling this the 20th anniversary of the Human Genome Project's completion. So all of these folks had labored without ceasing. Many of them for the entire course from 1990 until 2003. An amazing group of dedicated scientists. None of them worried too much about who was going to get the credit, just rolling up their sleeves, coming up with all kinds of creative solutions to the problems that we faced. 6 countries. This group, even though it's a large group, represents 2,400 scientists who work together to make this happen. And I will always be grateful to them and for the opportunity to have served in this role as the International Sequencing Project Director.
Okay, guys, we're at the hour mark. I've been working away off screen, and we've been watching this Francis Collins. I hope it's interesting to you. If you're watching, I'm going to put on a trailer, but before I do, I'm going to just ask that you hit that like button, because that is a good way to, for free, it costs you nothing to do, and it helps out this channel a lot. Helps kind of grow our community. So make sure you hit like right now. Yeah, you did it. I hope so. I hope you did too. All right. And with that being said, I'm going to go ahead and. Vic said it's just perfect without being anything. Exactly. Just that B is like, yeah, it kills me. Okay, let's put on the trailer for. Let's put on this trailer.
Hi, my name is Phil Chandler. I'm a freelance artist, illustrator, and cartoonist. Today, though, however, I want to tell you about a graphic novel I picked up recently called Jacob's Apartment. This book was both written and beautifully illustrated by Joshua Kemble. It is the story of a doomed romance that causes the main character to question his beliefs and his faith, while he's also going through other tragedies in his life. Every page has been illustrated by hand and digitally colored with painstaking detail. It is an emotional story that causes you to think and even question things in your own life. And while the story is a tragedy, it is one that I was completely entertained by and I highly recommend. You can currently find this on Amazon or even check in with your local bookstore and see if you can order it. And while you're at it, you can also check out my Instagram at Phil Chandler Arts and also my YouTube channel by the same name, Phil Chandler Arts. And go buy Jacob's Apartment.
All right, and did I hit the like button on the Francis Collins lecture? Yes, I did. That's actually a really good point. It's so easy when you're watching these things to not do that little thing that's going to help the algorithm. That be the question, matey. I love the pirate talk. I do want to kind of mention Philip Chandler has a really cool channel. He's the guy who did that kind of testimonial video, and it was very flattering to get from Philip because he's a really talented artist. But more than that, I don't know if I've mentioned this on stream, but at the point that I went to TCAF, it was my first time in Toronto at TCAF. I had really high hopes because of Jacob's Apartment having just been released. And being able to be at a booth of my publisher, it was a big deal for me because it was a bunch of new experiences that I'd worked really hard for years to get to. And it's hard to put into words how cool it was because Philip used to hang out on the live streams, for quite a while. He'd kind of show up and hang out and talk in the chats. And he's a really interesting guy. And the fact that he took the time to go to Toronto to hang out at TCAF to meet me and to hang out and eat some food together and express his care for my work was just it's a very meaningful thing because here I am in a completely different country. I've just flown from to an airport. I have no idea what the currency is. My card reader died, so I couldn't process orders for books that I smuggled on the flight. It was just a very disoriented and very powerful, awesome experience. But Philip was a big part of that being a really enjoyable experience going to TCAF because it's just very meaningful to go to a completely different country and meet somebody who actually likes your work and also is as encouraging and cool and also talented as Philip. He also has given me a cool drawing. I don't know if that's on my... Is that one of these? Let's see here. No, that was... It's on here. I'll find it at some point. Maybe it got pulled off somehow. No, this might be right back. I know it's on here. Nope. Just going through it. There's my Greenberg. Nope. That was a joke from a while ago. I know it's on my desktop. Anyhow, he did a really cool drawing of me as well. Oh, here we go. Let's drag this in here. I'll show it off. He also sent me this drawing, which is hilarious, and I feel like he really captured my likeness, right? So if you guys haven't checked out Philip Chandler, very nice guy, very encouraging guy. I know Adam and Vic are familiar. Um, Vic said, I love Philip even though I'm stuck shadow banned because of Frank. What is all this shadow banning talk? You guys have to explain that to me before I get back to the lecture. Frank was mentioning all this shadow banning stuff too. I'm like, what is this? What is this Frank shadow ban stuff? Okay, here we go. We're going to continue.
That's fine. What do we do with this information now? Well, we had to think about what's the next step here. And one of my jobs at that point, because I was leading the Genome Institute, was to try to come up with some kind of iconic way.
So, by the way, imagine me, like, you know, listening to this and then going on Christopher Runciman's chat room when he's doing his one-page comics, and he's like, hey, guys, do you have a prompt? And I'm thinking, gnome. You guys should check out what Christopher did with that funny prompt, but that's literally why that was on my mind. I was just like, gnome, genome. I'm a dad, okay, so I can get away with jokes like that. All right, let's continue.
Of describing where we needed to go next. And I was in a bookstore looking at books about architecture, and I had recently visited Falling Waters, Frank Lloyd Wright's
beautiful building,
not far from here in Pennsylvania. Oh, I'm sorry. I'll come to that in a minute. We have 20th anniversaries also in 2023. The Bachelorette, still going. SARS wasn't that a good one? Not SARS-CoV-2, but SARS, the original SARS. That was 2023. Freedom fries, remember that? Because people in Congress were mad at the French because they wouldn't join our invasion of Iraq.
I want to pause and just highlight that freedom fries stuff was real, dude. like, I was alive at that time, and like that was a bizarre thing that actually happened. People were protesting French fries because they were so mad at the French. This literally happened, you guys. Where French fries, which are like an American thing, they were like, we're mad at France, so we're calling them freedom fries. And there was a big constituency of people who actually were insisting on calling French fries freedom fries. They'd be like, I'll take a hamburger and freedom fries, please. This literally happened. That's like when I was at this point, this was when I was an undergrad, I believe, and I was going to college. There were a lot of protests. It was like a very active time because it was one of the first times we had been in a war that was just like clear cut, like in my lifetime, that was such big news, but it was also clear cut, just BS, like our reasoning for being there. And having been through like the September 11th attacks and stuff like that collectively, it's just a weird time to kind of talk about for anybody who might have been like really young at the time. But I mean, so imagine you're like early in college, you know, and there's this energy of just like anger at the administration for this stupid war that was just, I mean, it was really obvious that it was just like they had manufactured the whole reason for going there. They were saying like, oh, we need to go there for weapons of mass destruction. And they found out there's no weapons of mass destruction. And you find out that this was like Colin Powell just kind of making shit up. It's like, it's just, it was it was a really weird time and a weird era in time. But the fact that like the freedom fries thing, that's a really good thing to highlight from this era because that is how absurd things got. But anyhow, let's continue. Finding Nemo came out then. That's interesting.
Finding Nemo is 20 years old. Can you believe that? The Department of Homeland Security. I'm sure they're having a celebration today too. And yes, completion of the Human Genome Project. Once again, I would say, you know, go down the list. What's the one that will be commented about in 100 years? I'm guessing it's that last one.
Nice.
So back to the diagram. So yes, this was an effort to try to depict in a visual icon what happens now. Human Genome Project down there is like the foundation. And here's this building. And by the way, the door is open, inviting.
Vic said Finding Nemo is older than me. Yeah. And like what's weird is like a lot of this stuff. It's weird when you get to an age, at least where I'm at, where there's like huge historical events that like people even in their 20s now like have no idea like about, or they've like seen movies that are kind of like depicting these events, and it gives me a window into like how maybe my parents felt when I was like watching movies about the Vietnam War and like reading the history of it, and I'd talk to them about it, and they'd get into like the nuances of what actually occurred like in their viewpoint from that, you know, from the time they were there. And I'd be like, I know better, because I had like read stuff about it. But it is weird when you've experienced something, and at least culturally, like you've experienced something like collectively at a certain age range, that you just kind of would have to have been there to like fully understand the weight of it. Like even the war effort was like this weird time where, because of the attacks, like the entire country was like, including myself, was like f anyone who's not American, like, you know, very pro America. Because you watch these like, I mean, it was really bizarre, you know, like I think I was at a friend's house and we thought it was like an action movie they were watching when those towers fell. And so like the way that kind of created this like very united front with like everyone, like I didn't know anyone who was like at least the day or two after, like nobody was talking skeptically about anything. Like we were just all like united and kind of ready to go to war. And it's bizarre that like to have lived through that experience where everybody collectively was very like pro America, and yet like it became this like very strange thing that when used by the wrong people, kind of misguided like the entire country into a really unjust war. And just the manipulation of that, like at a time where they actually should have been like targeting specifically who was responsible for it, but some opportunism kind of came up and they kind of redirected. They're like, nah, let's go here instead. And in retrospect, it's clear as day. But you know, at the time, it wasn't so clear, and that's that. I think that's the thing that helps me. Like when I hear about history before me, is like what's mapped out and obvious in like retrospect. Like in the moment, like when you're in the weeds or in the trees, you're not going to see the forest. And so it's an interesting thing having been in one of those moments. Anyhow, let's continue.
Everybody to come in and work with us. And in this simplistic view, and there's a much more elegant view. If you didn't pick up one of these, by the way, on the table out there, you should, because it gives a much more nuanced perspective these days of where genomics is going. But a simple definition here, we might have divided this up into biology, sort of the science of understanding the genome. How does it apply to health? And then how does it apply to society?
Yeah.
The Genome Project from the beginning had been unique in thinking about those ethical, legal, and social issues, the so-called LC program. And more than ever, now that the genome really was in hand, you needed to think about what measures need to be taken to maximize the benefit and minimize the harms. You'll see the vertical pillars that hold this all together. And looking back on this, I think we were actually looking ahead pretty.
Sorry, how charming is that Francis Collins, this geneticist, is like taking a trip to Falling Water, and then he makes this chart kind of showing where they're at based on Frank Lloyd Wright's Falling Water. You know, I don't know. I think that's adorable. That's all.
Effectively for 2003, resources, yeah, technology, oh my gosh, computational biology, training, LC, education, all of that, holding the building so that these three floors can all flourish and flourish interactively. So how did we do? Let's talk about the LC part. The big concern at that point really was, now that we have the opportunity to give everybody their own DNA information, which you might want to have, and we've talked about that a lot today, will it get used against you? Will it be a reason for your health insurance to be canceled? Will it be a reason for your employer to say, maybe not such a good person to invest in for a promotion, might get sick later?
So this is a huge thing with DNA, that like he's going to get into like some of the ways that they hedged against this, but this is a major concern that I'm glad, like, again, weirdly enough, like it's kind of encouraging. It's encouraging to watch a lecture like this that's for the people working on this kind of project. You know, it's like a celebration for them to kind of look at like, hey, look at what we've done, look how far we've come, like look where we're heading. And I do think it's encouraging that there are a lot of people spearheading this kind of research that have the same concerns that like a lot of people would have, right? Where they're like, hey, like this is great. We're going to cure diseases with this, you know, like we're going to actually get some really real positives for society. But like, what's the implications if your genetic data ends up being, you know, used against you? Like, you know, let's say I take like a 23andMe test, and then the next time I'm like applying for a job, people are like, hey, you have this gene. I'm sorry, we can't hire you. You know, like it's a huge thing. What if, you know, like you're denied different opportunities aside from insurance, you know, because of your genetic makeup and stuff? This is the stuff of science fiction, but that could very well be a reality. And like you know, again, it's just kind of encouraging to me that like there's people at the top that are concerned about that as well. And I don't view it as like faux concern. Vic said, I'm finally writing something good for my Abea man thing. What's Abea man? I'm curious. Okay, let's continue.
I think I'll pass this person over. Those were very real issues. They were happening to real people. I think anybody who thought deeply about it would say, you didn't get to choose your DNA. It should not be used against you. But there was, at the time of 2003, nothing to stop that. Now, that effort to try to come up with a solution, a legislative solution against genetic discrimination, actually got started back in 1996 as part of the LC program. And there were papers published from workshops that basically laid out how to do this and what it would take, but it wasn't really catching much momentum. A person who wrapped her arms around this very early on was Congresswoman Louise Slaughter, for whom this lecture is named. And I got to know Congresswoman Slaughter almost immediately and had innumerable opportunities to talk about where is the window that might open up to get something like this moving forward in the Congress. You can imagine who was against it. The health insurance companies are like, well, don't worry. Well, we won't ever do much like that. They don't want to have their hands tied. And of course, the employers, they don't want to have their hands tied either. And so there was substantial pressure, and it took year after year. And you would think, oh, we're getting close. Here's where I thought we were getting close. This is 2007 in a picture, and that is Louise Slaughter in the picture with a bunch of staff from NHGRI and others from director's office. And her inscription there is, thanks for this best of DNA days, Louise Slaughter, April 25th, 2007.
So I think this is really, sorry, I have to double check the, okay, we're not, I have to look at previous pages. Okay, so we're not that off from what we need. Okay, cool. So again, it's like, it's interesting. Like, so you imagine like somebody running this like giant center where like their whole goal is to like decode the human genome and make like genetic discoveries and stuff that'll help cure people. And they're going through this, and a bunch of these scientists are like, hey, this could be or maybe not all of the scientists, but at least, you know, one of the guys at the top is like, hey, this could be problematic. Like, this could actually hurt people if this data is used wrong. We need to kind of set something up to like prevent that. And they're advocating with, you know, like leaders in the government to try to actually set up some ground rules, right? So that things can't go astray. And I love that. I love the fact that one of the people heading this, like one of the people making sure this research is getting done, is also a huge advocate for keeping their hands tied a little bit in what they can do once the data is out. And that's, again, like that kind of, I think, goes against like this narrative of like these evil scientists like trying to do terrible things. Now, don't get me wrong. I'm not going to totally defend scientists in this sense. I mean, the Manhattan Project is a really good example of a scientific innovation that's probably one of the most wondrous things we've ever done as human beings, and yet also could potentially destroy the entire world, right? And that was science, just that in a weird way, because of the fact that like progress does not slow down. Like if we hadn't unlocked that, a different group would have unlocked it, because we were on the brink of that discovery when you know they figured out like the atomic bomb and stuff. But it's like at the same time, like that's not something I'd look back at and be like, wow, science did a wondrously good thing there. They potentially put the world in more danger than it's ever been in like in all of mankind. So I'm not saying all scientists are great, or you know, in fact, there's a history of like some pretty bad meaning scientists, because like when you're just trying to discover truth, but you kind of take ethics out of the equation, it can become really dangerous. But it's encouraging to me that there are people doing science that have an ethical concern as they are conducting it and are trying to put some checks and balances on the process so that, you know, it can't just run amok. Adam said, cool. Yeah, I don't know if the test I did will check my ancestry, but I have a pretty good idea based on other family members who have done it. Nice. That's cool. So you're doing that. Oh, he said I recently sent out DNA to test to see if I have any specific sensitivities to food and other medications, like being prone to certain diseases. That's awesome. I've wanted to do a genetic test for a long time. Vic said, I want to do one of those tests to figure out what type I need to consider myself, because right now I say I'm Irish because I think that's a big part. Yeah, it's not bad to know, like, you know, where you come from. Vic said, I need to because I get a different answer every day from a family member I go to. Wouldn't it be funny if you took the test and you were just like, you know, completely like everything but Ireland? And the whole time you've just been like, I got my Irish. And it's like, wait, oh, you're not. I have some Irish from what I've been told. But again, it would be fun to kind of get that hard data, right? And a lot of people don't even realize that, who are like super critical of science, is like a lot of people will take a 23andMe, or like, you know, they'll watch like a murder mystery where like DNA is used to find a murderer, and they won't question that. But like that's all the same stuff. It all depends on this genome. Okay, let's continue.
7. So you might have thought, okay, they passed it. Well, no, they didn't quite. That was another sort of disappointing year, but it finally got better. And so this is 2008. This is a moment I will not forget. This is the moment where the House of Representatives, moments earlier, have passed the Genetic Information Non-Discrimination Act with good confidence that the Senate would do the same with the same version. Senator Ted Kennedy, who'd worked really hard on this on the Senate side, walked across to Congress, which senators don't usually do, and came and sat with us in this little room off the gallery of the House of Representatives, which used to be used for reporters to call in the latest of what's happening. That's those funny phone booths behind the members here. And so, yes, you'll see starting on the right, Anna Eshoo, Judy Biggert, who was the lead in the Republicans for this. I mentioned Ted Kennedy, Louise Slaughter, who had been so faithful to this. And I would say the main credit for actually getting this done had to go to her. And then Congressman Andrews from New Jersey, who'd also pitched in to get this across the finish line. And not long after that, we're in the Oval Office, and President George W. Bush, May 21st, 2008, is signing the bill in front of a small group of us. And I will say, after he signed it, I asked him if I could have the pen. Sometimes they do that. And it was like, no, that's going to my library. So I assume if you go to the Bush Library, you will see the pen that was used to sign this most significant piece of legislation about genetic discrimination ever. But I don't have it. But he graciously then sent me afterwards a copy of the bill with an inscription there, if you can read his handwriting, which is a little challenging. This was a really big deal. This is not to say that we fully addressed all of the issues with genetic discrimination, because they are still out there, and there are even threats to this particular law by.
Okay, guys, we're going to continue a little bit. I think I'll go for another, like maybe like 20 to 30 minutes, because I'm making pretty good progress. I think that I'm going to play another trailer and get a refill of water so that I am sustained and don't ruin my DNA. I don't think drinking water has anything to do with that, but I was trying to be topical. Okay, let's see here. Let's put on this trailer, and I will be right back. Believe this is Mr. Runciman.
Hi, my name's Chris and I like comics. I want to talk about this comic for a second here. I just got this in. I ordered it direct from my local comic shop through Diamond Distributing. It's Joshua Kemble's Jacob's Apartment. I really enjoyed this book. There's all kinds of comics out there, let's be honest. There's fun comics, there's superhero comics, there's young adult comics, there's adventure comics for kids. There's so many different things under the planet. But there's also an entire subgenre of alternative books. Real life, real world depictions in comic book form. Situations that happen to each and every one of us. And this is a fine example of that. If you get a chance, order this book from your local comic shop. You won't be disappointed. I can't sing its praises high enough. Okay? Check it out. Jacob's Apartment by Joshua Kemble.
Okay. Let's get back to it. Hopefully this is interesting for you guys and you're getting some art made and your brain fed a little bit. And let's continue. Let's see. Vic said, I'll explain Obaya to the best of my ability when you get back. Okay. Let's hear it. I'm curious. Okay.
Employers. And certainly, if you're contemplating getting DNA information about yourself, you should recognize that you're not protected against discrimination in other areas of insurance, like life insurance, like long-term disability. And you can kind of see why that might be because of what would be called adverse selection. If you know that you're at very high risk of Alzheimer's disease and you're fine right now, and you want to buy a policy that's a very expensive one without revealing that risk, eventually that is going to destabilize the way in which insurance works. I kind of get that, but I still don't like it. And so states like Vermont that have decided we're just going to protect people against that kind of discrimination. Anyway, my hat is off to them, but it's not safe in other places. So you should think about that before you decide to have a genetic test.
Vermont in the house. Okay, let's continue.
So that was a big deal. Now, there's a lot of things happening in the ethical, legal, and social issues. And you already heard about one of them in a very wonderful panel this morning that Vince Bonham led, which is this report, which just came out. And again, it's very well written. It's worth diving into. And for genetics researchers, this is a really helpful way to guide us in terms of how exactly we use population descriptors in genetics and genomics research, recognizing that race and ethnicity are freighted with all kinds of misunderstandings, and lots of things go into those that have nothing to do with genetics. In fact, most of what goes into them has little to do with genetics, and yet they are still used awkwardly and sometimes misleadingly in science research in a way that has not really benefited anybody. So this document, I think, is a very good way to point out a better direction. And I like the quote which Vince sent me as sort of a good...
Wait, guys. Do you think it's a better direction or a new direction? But no, that's cool. I mean, like, if you think about it, trying to set some guidelines there, too, so that people aren't misusing, like, scientific data to, like, kind of make, like, weird, like, race claims or... You know what I mean? Like, there's a lot of people out there who really like misusing scientific research and quite often just ignoring the conclusion of the scientists themselves and like just digging into all the different data points, misusing them, and then saying, you know, oh, this supports my agenda or this supports my agenda. It doesn't just happen with like racists, but it also happens with like religious people. It happens with anyone who can kind of glean that data and kind of use it to their own advantage. And so I think like any sort of like parameter that you're setting up to like protect people is like a really good thing. Oh, okay. Vic said it's basically just a term, witchcraft in select Caribbean countries, especially Jamaica, who talk about duppy, which is a kind of ghosts or demons. They come from improper burial of the body. This is all from Vic. Either resulting in the spirit going for revenge against their enemies or protection of a loved one. Interesting. Sounds like good material for like a story. Okay, let's continue.
Example of the way in which this report comes forward. Although imperfect, categories and labels are needed. It's not like saying, well, we're not going to say there's any differences between us, because there are, between our ancestry and our environmental exposure and our culture and our social experiences. We need those in some way, but transparency requires stating the rationale behind the classification scheme you are using and what group labels you're applying.
That's
so
awesome.
that it is not immediately misunderstood. And I think that's a very important set of exhortations to all people who are doing genetics research. Meanwhile, of course, we had to figure out how to take this 3 billion letters of the human genome and turn it into something that would help the medical situation. This cartoon of two physicians just looking at A, C's, G's, and T's and trying to help the guy in the hospital bed. That's not the answer we want. You want to have information about how this works.
Okay, so I want to interject here too. Like, I think this is one of the coolest things about, like, if you're ever bored, like, this is something I always keep in mind when I'm exploring philosophy, when I'm exploring anything, any sort of information. I kind of look at it and I go, is this applicable in any way? Like I do think practical science is a really important thing. Like you want to kind of think why and what can this do to benefit people, right? And I do the same thing if I'm like reading philosophy. Like if I'm reading a philosophical book, there's some ideas that are really fun, but I'll ask like, is this practically applicable to me? Is this going to improve my life? And not that I won't necessarily like entertain an idea, but when I'm thinking about like my own personal ethics or something like that, or when I'm thinking about, you know, like if I were a scientist, right, I would be thinking about that. Like, how is this data that we're collecting actually going to benefit people? And I love that step. Like, that's the interesting thing about science is it can kind of start with things like we need data, right? And then from the data, you start going, what can we do with this data to like help people? And it's pretty cool, you know. Again, at its best, it's pretty cool. At its worst, it can be horrifying, right? So, you know, because again, if the ethics don't come into it, then it becomes like it can become just like this cold data collecting machine that can be really dangerous. And so it's an interesting thing. But again, it's fun to get to that point where it's like, okay, they've got, you know, 60 years or whatever research. So at this point, what are they going to do with it? And I love that step in science. It's one of the funnest. Or most fun. Funnest, I don't think is a word.
And an awful lot of what's been going on in the course of the last 20 years.
Let me just say, that's the point in this video where like if Francis Collins, which he won't be watching it, but if he was watching this video where I was making fun of like one little mispronunciation, that's the point where he pauses and goes, sucker. He's like, yeah, that's right. That's right. You said funnest. Okay, let's continue.
That relates to genomics has at least an indirect implication and sometimes a very direct implication to trying to answer those questions. And for me as a physician, this has been a driving force of trying to be sure we're doing everything we can to accelerate that process of developing genomic medicine, you might call it precision medicine, So an awful lot of things got done by the Genome Institute, working oftentimes with other partners. Lots of these projects following the same kind of ethics as the Genome Project of let's bring a lot of people together, let's
Yeah.
get them to work on a really hard problem and then give all the data away. And that's what happened in many of these. And it's continuing to this day. This is an incomplete list, to be sure. But maybe it would be appropriate to highlight a couple of the things that have happened. There's our Nature cover. And here's what basically Adam Philippi and his colleagues.
I got to pause here. So Nature, like, again, like, I don't know if people, I think people understand this. I like to think people understand this, but the last year or so, I don't know how many people understand this. Like, Nature is a big deal as a magazine. Like, this is you know, like a pretty monumental thing. And if something's published in there, you bet you everybody in the industry is going to try to debunk it. Like, because again, like, that's kind of how science works. Like, if you're able to take like an existing theory and just turn it on its head or disprove it, you have just made yourself, like, super famous, like in the industry. So there's like this baked in incentive in science to like refute and disprove claims, and so it kind of creates this generation engine. But that's why like scientific journals are super important, as are like double blind studies, because you don't want like bias observers like fudging the data just to like get the result they want. Anyhow, let's continue.
Particularly Karen Miga, were able to do with the new technology that you may have seen him talking about in that video, which allows you to do very long reads and therefore to get through these regions of chromosomes, the centromeres, the telomeres, heterochromatin regions that are very highly repetitive. And imagine if you're trying to reassemble those and the stretch you're trying to reassemble runs over tens of thousands or hundreds of thousands of base pairs, and you have pieces that are only a few hundred base pairs. You just can't figure out how to put them together if they're all kind of the same. But with a long read, you can do that. And so the so-called T to T, telomere to telomere project has finally, I guess, put an end to our celebrations of completing the human genome. We've had a lot, darn it. Adam, you ruined it for us. From now on, we have to admit it's actually done. But bravo for that. And that
I like
technology
that.
is also going to be really helpful.
They're like, man, that shouldn't have been resolved. We kept having cool parties.
Other things that are happening in the technology arena that deserve notice, I just can't say enough about how dramatic it is that we can now do genomics on single cells. I mean, think about it. What do you think of the three most significant insights in biology in all of human history? Well, one would be evolution. One would be DNA as the hereditary material. And I think the third one would be cells, that cells are the unit of all living things. And if you want to understand life, you need to understand cells. And yet we have not, until very recently, been able to ask just one cell, hey, what are you doing? And we can do that now. We can ask that cell, what genes have you turned on and which ones are turned off? And even how much have you turned them on? And we can ask that cell, what's the state of your chromatin? Which parts of your chromatin are sort of open?
The immature part of me is thinking these are just incredible pickup lines for a nerd. Or you could just be like, hey, what's the state of your chromosomes? Which sequences are turned on and turned off in your DNA? It's so bad. Okay, let's continue.
For access to transcription factors and which parts are closed. Single cell biology, single cell RNA-seq and single cell ATAC-seq approaches that people are taking. And while we could, I guess you could say we were studying single cells if you were doing it in a laboratory, growing cells in a culture dish and they were all identical, well, okay, then you could study a few million of them and you'd kind of know what happened to that original cell that gave rise to that. But that's not the way human biology needs to be studied now. You want to look in that person. You want to know exactly all those cells in the pancreas. That's what my lab works on. All those cells in the brain. There's a huge effort there. What are each of them doing? And the complexity you uncover is breathtaking. Because if you don't have the ability to look cell by cell and you just have to mush everything together and see what the average kind of cell is doing, you're missing most of the exciting stuff. Single cell biology, for people who are interested in this field and think maybe all the excitement has already happened, this is like going to be transformative, and particularly so for the brain. Oops, I went backward or something. Oh, I'm suddenly... That was...
By the way, so there's some other Colin stuff that I definitely am going to want to highlight. I just like, and I might, do another video of like watching those, but this one's just like a really interesting recap that I found really encouraging, strangely enough, about like the progress that we've made on the genome and kind of where that's left us. And again, like, just imagine like for your stories, how important like stuff like this is. It's like, let's say you're going to write a story about X-Men or something, and you want to talk about genetic mutations and stuff. Like, dude, pick up some Francis Collins. You know what I mean? Like, check out some of the stuff that the NIH has done, and then like that can kind of inform your fiction. This stuff is great. It's just great, and it's also just kind of encouraging from like a kind of more humanistic perspective. Okay, let's continue.
Weird. Okay, we're in the forward motion again. A huge application that has made a big difference in understanding the most common diseases, things like diabetes and heart disease and Alzheimer's, is this ability to scan across the genome, studying lots of people, and find those places where there are small differences that have an effect on individual risk. And this is the genome-wide association study, or GWAS approach. You need DNA from controls and cases that are well characterized, and you need to be able to genotype all those people, and then you scan across the whole genome and you say, is there a place where the people who are affected have a higher likelihood of this particular spelling of this particular variant? And there's statistics to tell you whether that's actually real or whether it's just noise. That has been transformative. My lab that works on diabetes, we're now over 600 places in the genome where there are absolutely convincing variants that play a role in this very common disease of diabetes. And it's hard to sort all those out and figure out what they're telling us about the networks and the pathways that are involved, but that is the best insight we're going to have for a while in terms of the ways in which these common diseases come about and why they run in families, but not in easily understood ways. One of the things that will help us with that, which I need to give a little shout out to, and which Josh Denny was here this morning, is now the leader of, is this project called All of Us, which aims to try to figure out how do those genetic variations that we all have, our environmental exposures, our health behaviors, our medical experiences, how can we make sense out of that to really do a better job of what you'd call precision health? Not
You guys, isn't this fascinating? So, like, from what I'm understanding from what he's saying, it sounds like they have, like, now the game of like research, I guess, to kind of look into diseases and their genetic factors behind the diseases is like, now that they have the genome, right, they can run like a computer program. Like, they have a genome that's like a healthy, like the full code, right, of the DNA strand or whatever, of a human, of the DNA of humans. And so because they have that, they can run a computer program that runs like, versus like, it takes like normal human DNA, like a healthy human's DNA, and scans a bunch of people who are unhealthy and their DNA, like the people with specific diseases, and see if there are variations, like where are the letters changing, right? Like, where is the spelling different in this DNA? And if they can kind of isolate that and then start figuring out what that is causing and what that is doing, they get closer to a potential cure. And that's kind of amazing. And that's possible because they have the raw data to kind of compare against, right? If they didn't have that like basic data of like, this is what the code is, this is what the whole thing says, now that it's almost like running spell check. Like, right? It's like they get to run like spell check on your DNA and go, where's the misspelling? I just think that's pretty badass. Oh, Vic said I'm gonna tap. See ya. Yeah, I'm probably gonna tap out, and if let's see here, where are we? When are we tapping out? We're probably gonna tap out in about 10 or 15 minutes. So I appreciate you hanging out, Vic, and I hope the comics are coming along well, and I hope this was super inspiring for you, buddy. Yeah. But I think that's kind of a cool idea, like the fact that they're technically kind of doing like a spell check, you know, a spell check of your DNA. That's amazing. And again, much like spell check, if they don't have the data that's telling you the proper spelling, they can't run that, right? You can't run spell check if your program doesn't know what to check against.
Not one size fits all, but precision health. In case you're not part of this and you're 18 or over, joinallofus.org is up there, and you can find out how to get on board, because we're aiming for 1 million. And as you can see, we're a little over 600,000. So there is still time, but there won't be time forever. All of these folks actually make their electronic health records available. They fill out all kinds of questionnaires. I'm part of this. I'm always getting hit with a new questionnaire, but I always answer. And it becomes this incredible, valuable database that anybody who's willing to assert that they're not going to try to identify individuals and a few other things have access to the data. It was just a few days ago that they released 245,000 whole genome sequences on all of us participants. That, at least for the moment, I think it's the largest collection of whole genome sequences of any project. And that is going to be just amazing. And researchers are already plunging in to see what they can learn there. Cancer, of course, has been just a profoundly important part of what genomics has done in terms of medical issues, in terms of things that are happening right now.
So this is like just showing you like real world applications of like where they're getting with this research, which is pretty cool. So let's continue.
The clinic, I ran up in the middle of today to see a patient upstairs who is in the process of a human clinical trial for cancer. And it's because of genomics that this patient is receiving a very precisely focused approach to his cancer based upon a precise knowledge of what exactly is driving the cancer for him, which genes are misspelled, not on average, but in his tumor. And how can you match that up with the available therapeutics, be they chemotherapy drugs that are designed to be very targeted, or be it immunotherapy? And cancer is so different now than it was 20 years ago because of all of this. And for rare diseases, that story I told you about how painful it was to try to find the cystic fibrosis gene, and this has totally changed because of the availability of the genome sequence and the technologies that allow you to track down those causes. Back there when the Genome Project started in 1990, you can see there were 68 rare disorders where we knew the molecular basis. The number now, 6,800. And that has increased drastically, especially.
Sorry, 68 to 6,800 is kind of that's beyond exponential growth. That's kind of amazing. Oh my gosh, you guys! I have to call it because it is past 2:00. I want to finish this lecture though, but I think what I'll do instead is encourage you guys to actually check out the full lecture. It's the 2023 Louis M. Slaughter National DNA Day Lecture by Francis Collins of the National Human Genome Research. Hold on a sec. What's the full channel name? Research Institute. So I encourage you guys to check out the full thing. It's really encouraging. It ends on a very happy note. And also we do have 2 more things. So I was going to wrap, but I actually have 3 or 4 more things I got to do on my art page. So hang on. Let's actually watch a little bit more. But I'd encourage you guys, we are going to have to stop at some point very soon. So we'll watch a little bit further. But yeah, I encourage you guys to check out the full thing. Okay, let's watch the rest of this not the rest of the whole
thing.
For
cystic fibrosis, which I think took us 7 years, and that was more than one group working sometimes together, sometimes not, and all kinds of people who got burned out along the way. 7 years. I would think a pretty good graduate student with access to family DNA samples, a PCR cycler, and a DNA sequencer could probably have done that in 1 week. Because that's the way it is now, with the ability to speed everything up with the technology that's changed. So that means these 6,800 conditions can now be effectively and accurately diagnosed by simply going and looking to see what is that DNA misspelling. But of course, you don't want to stop there. You want to have something to offer people who have those conditions, many of which are very rare. And I'm sad to say that even now, the number of these that have an approved therapy is only about 500. So we have a huge need here, a yawning gap between our diagnostic ability and our therapeutic ability. But there is a lot of hope to see that beginning to close, although much of it still lies ahead. Gene-based therapy.
Okay, now I'm ready. Thank you guys. Adam said fun stream. Have a good one, Josh. You too, Adam. Thanks for hanging out. All right, well, thanks guys. Thanks for hanging out on my live streams. I've done like 3 or 4 today, or I should say like yesterday. I'll probably be doing some live streams later tonight as well. And maybe we'll check out another Francis Collins one where he talks a little bit more about philosophy and stuff. He's a really interesting guy. But the more you dip into like DNA, RNA, all of the like kind of science going on with it's really fascinating. Okay. With that being said, I am not a scientist. I am a cartoonist, and I appreciate you guys hanging out with me while I'm working on my comic, Not Death But Love, The Strange Supernatural Story of Elizabeth Barrett Browning. I'll give you a little spoiler about what might be coming soon on my channel as well. I'm going to unzip this little case and pull open this. This thing is a lavalier mic, right? And so I do these vlogs when I'm driving home from work, and I enjoy doing them, but one of the things that sucks about the vlogs is the audio quality is awful. Because you have like the AC running, and because of the part of California I live in, there's just no way you can record like without your AC on. And so I'm hoping this will solve the issue. I'm probably going to do a little test on my drive, so I can just clip it here, and the audio goes to Bluetooth, which goes to my phone. And so like in theory, that should kind of solve the issue and give better audio for the vlog. So I'm going to try to test that if I have stuff to talk about on the way to work or from work. And then you guys will be able to see on my vlog whether this little tiny, it's funny, it looks like a little mini mic. Hello. But I've tested it a little bit, but I want to test it in the car and see if this like ups the quality of those car vlogs, because I think that would be really cool, because I don't want you guys being tortured by bad audio. So anyhow, I am going to be doing stuff like that, like getting a little lavalier mic just to kind of improve the audio quality in the car. At some point I might be improving cameras and stuff like that. So I'm investing a little bit in trying to make this a better experience for the people who are subscribed to this. And all I ask is hit that bell, hit that like, and the bell so you get notifications when we're about to go live. And if you have any comments, leave them in the comments section. All right, guys, I'll see you tomorrow, and we'll work on more comics. I hope you had a good, productive day. And and if you're bored, go down a rabbit hole and check out Francis Collins. He's really inspiring. Thanks for keeping me company whilst working on comics, and I will see you guys later. Bye.